riset ilmu-ilmu terapan yang mendukung pengembangan engineering dan teknologi. Pendidikan teknik fisika tumbuh di Indonesia atas prakarsa Ketua Fakultas Teknik Universitas Indonesia yang memandang perlu mengisi lapisan pemisah antara sains dan teknologi. Pada tahun 1950 yang mendukung ahli teknik fisika asal Belanda, Profesor Dr. Insinyur Pendidikan teknik seorang ahli fisika teknik Natuurkundig Engineer ditunjuk untuk mengelola jurusan pendidikan teknik dengan nama Natuurkundig Engineer Afdeling. Pada tahun 1959, pendidikan teknik tersebut diberi nama Bagian Fisika Teknik yang tergabung dalam Departemen Fisika atau Teknik Fisika dengan Ketua Profesor Insinyur M.U. Adiwiyogo. Selama perjalanan sejarahnya, Teknik Fisika ITB mengalami beberapa kali perubahan struktur organisasi. Tahun 1963 menjadi bagian dari Departemen Fisika Teknik dan Teknologi Kimia. Tahun 1972 Tahun 1980 menjadi jurusan Teknik Fisika, tahun 1999 menjadi Departemen Teknik Fisika, tahun 2005 menjadi Program Studi Teknik Fisika. Pendidikan Sarjana Fisika Teknik memiliki kegiatan laboratorium untuk mengembangkan diri mahasiswa lebih lanjut dan menjembatani konsep pengetahuan fisika yang modern dan terkini. Lab material meliputi pengetahuan dan penelitian tentang semua jenis material, proses dan analisa, komputasi, perancangan, dan kerekayasaan material. Lab proses material, ilmu mengenai material memegang peranan yang sangat penting dalam perkembangan teknologi di berbagai bidang, seperti industri transportasi kimia, energi, elektronika, dan kedirgantaraan. Lab Functional Material memiliki fokus pada penelitian nanostructure material seperti doping functional materials, variation of synthesis process, dan variation of nanopattern sehingga dapat diaplikasikan bagi lingkungan maupun energi. Lab Komputasi Material. Rekayasa komputasi material adalah kegiatan rekayasa yang memanfaatkan komputasi sebagai alat bantu, terutama pada tahap pengolahan data, perancangan, dan pengujian. Memiliki fokus mengembangkan ilmu dan teknologi fisika kuantum, dan merancang material baru menggunakan teknik komputasional. Lab Fisika Bangunan. Fisika bangunan merupakan bidang keilmuan yang terkait dengan lingkungan terbangun atau built environment, seperti akustik, kajian termal dalam bangunan, tata cahaya, serta penggunaan energi dalam bangunan. Lab Akustik. Bidang akustik melibatkan akustik arsitektural kualitas suara dan akustik musik tradisional, penilaian kebisingan lingkungan dan industri, kontrol suara aktif, sistem pengukuran dan instrumentasi akustik, pemodelan pengenalan dan analisis ucapan, komputasi dan simulasi akustik, termoskustik, respons otak akustik, dan akustik fisiopsikologis. Lab Tata Cahaya. Cakupan teknik dan desain pencahayaan melibatkan kinerja pencahayaan arsitektural, interior dan eksterior, kenyamanan visual, penilaian pencahayaan lingkungan atau silau, desain reflektor atau refraktor untuk perlengkapan lampu, pengukuran flux luminus dan intensitas cahaya untuk lampu atau luminaire, serta evaluasi dan pemodelan pencahayaan alami. Lab Teknik Kondisi Lingkungan. Laboratorium Termal dan Kondisi Lingkungan atau Lab TKL adalah sarana untuk menyelenggarakan pembelajaran secara teoretikal maupun praktikal dari aplikasi, implementasi dan operasional dari rekayasa termofluida dan sains termal atau Thermofluids Engineering and Thermal Science. Lab TKL menjadi tempat di mana rekayasa lingkungan termal binaan atau Built Thermal Environment Engineering dikaji, ditelaah, dipelajari, dan diterapkan. Lab Instrumentasi Industri. Bidang keilmuan piramida sistem otomasi termasuk alur sistem informasi pada otomasi industri yang terdiri atas plant or field level, process automation level, business and management level. Lab Sistem Instrumentasi. Lab Sistem Instrumentasi fokus pada penelitian dalam pengembangan keilmuan pada instrumentasi dan kontrol berbasis komputer seperti mikroprosesor, DCS, PLC, dan lain-lain. Lab Intelligent Control and Automation. Laboratorium Intelligent Control and Automation fokus pada penelitian, pengembangan teori dan aplikasi kontrol, serta perancangan aplikasi dan integrasi teknologi terkini, PLC, DCS, SCADA, HMI, pada sistem otomasi industri. Lab Ultrasonik dan Tomografi. Lab Ultrasonik dan Pencitraan fokus pada penelitian dalam pengembangan keilmuan pada bidang pengukuran dan pencitraan secara umum, serta penerapan gelombang ultrasonik untuk uji tak merusak atau non-destructive task, pengukuran dan aplikasi lainnya. Lab Manajemen Energi. Teknik fisika sebagai multidisiplin field memiliki pengetahuan untuk menganalisa fenomena fisis yang kompleks, seperti yang ditemukan pada sistem energi. Dengan meningkatnya kebutuhan energi dan konservasi yang beragam, dibutuhkan teknologi yang berbasis pada energi, baik itu melalui kegiatan riset maupun akademik. Lab Instrumentasi Medik. Lab Instrumentasi Medik memiliki fokus utama dalam bidang alat-alat bantu medis, instrumentasi atau alat ukur biologis, alat tes fisiologis, pengembangan produk dan alat biomimicking, serta bidang pemrosesan citra medis guna keperluan peningkatan kualitas diagnosis dan intervensi medis. Lab Optik. Lab optik dan laser memiliki fokus utama pada pengukuran menggunakan metode optik dalam berbagai bidang, dengan keunggulan pengukuran tidak merusak. Selain itu, dilakukan pula pengembangan tomografi optik, serta metode perekaman optik dan pemrosesan citra untuk uji kualitas.
Dengan visi menjadi program studi kelas dunia, serta untuk menjawab tantangan revolusi industri 4.0, Teknik Fisika ITB siap menjadi program studi yang menghasilkan sarjana yang memiliki kompetensi kuat untuk menjadi insinyur profesional, peneliti, maupun entrepreneur, dengan selalu mengedepankan visi sebagai ID inventor dan teknologi inovator. Penemuan, inovasi, dan prakarsa akan selalu menjadi tujuan Teknik Fisika ITB dalam pengembangan ilmu pengetahuan. Dengan semangat profesionalisme, determinasi, dan konsistensi yang diimbangi dengan etika, empati, dan kepekaan terhadap lingkungan sains dan engineering, akan terus menjadi jiwa Teknik Fisika Institut Teknologi Bandung. Dan konsistensi yang diimbangi dengan etika, empati, dan kepekaan terhadap lingkungan sains dan engineering, akan terus menjadi jiwa Teknik Fisika Institut Teknologi Bandung.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Selamat sore. Good afternoon, everyone. So our participant is only Dion. Dion?
Ya, halo.
Halo. Dion,
Ya,
mau pakai bahasa Inggris atau bahasa Indonesia aja nih? Karena Dion dari BPK Penabur Sukabumi ya.
iya, boleh bebas.
Bebasnya berdua aja ini soalnya kita nggak apa-apa ya. Mungkin teman-teman yang lain belum selesai sekolah kali. Jadi belum sempat, nanti biar teman-teman yang lain nonton di itu aja ya, di YouTube begitu. Karena kita juga ini sambil live di YouTube ya. Oke, so Dion, do you prefer in bahasa or in English? Up to you. Bahasa Indonesia aja lah ya.
Ya, boleh.
Campur-campur lah ya, nggak apa-apa. Oke.
Ya.
So thank you for attending this event. Okay, so this event is about the International Graduate Program, ya, atau jalur track internasional, program internasional. Bukan program ya, kita lebih ke track internasional. So this is engineering physics. So in bahasa teknik fisika, okay. So in English it's engineering physics, not physics engineering, okay. So the admission is started from February 2022. So it's happened last month, okay. So because today is March, and the program will commence in August, okay. Jadi bulan Agustus itu akan dimulai sama dengan program yang reguler biasa ya. Okay. So in engineering physics, yeah, so our objective or aim is we utilize the broad principle of physics, okay, to solve various engineering problems, yeah, to tackle 21st century engineering challenges and to advance the future. So in a sense, engineering physics is a bridge between science and engineering. So everything, advancement from science to engineering, we put our best effort to put the solution from science to engineering. So because in some engineering program, it's really hard, okay, to apply science from physics, chemistry, and maybe math, okay. So some of the engineering program already only use the mature engineering methods, okay. So in engineering physics, we advance the new findings, okay. Jadi kita ngambil new findings dari science ya untuk diaplikasikan di engineering. So the solution is quite broad and it's quite futuristic, okay. So if you want to be a futuristic engineers, so engineering physics is the best program for you. Okay, so next is why you should study engineering physics. So this is a big question, why you have to choose engineering physics, because we not talking about today, we also talking about what will happen in the future. Because in the future, because we know that today we coming into the era of internet, when everyone is connected through apps and maybe shopping marketplace, and then all information. And in the next future, internet will be the needs, okay, and AI and machine learning will be the needs, primary needs for human, because almost all social areas will be connected to internet, and then our daily life will be dependable, okay, will depends on what will happen in the internet, okay. So that's what is the future, okay. So the industry 5.0, because today is industry 4.0, and we will advance to the 5.0, where the social is really needs everything from internet and then AI. And then we know that engineering physics is the key, because it connects everything, every disciplines in engineering and science, okay. So the engineering physics, okay, we prepare students, yeah, to apply physics to tackle 21st century engineering challenges and to apply engineering to address 21st century questions in physics. Ya, jadi teknik fisika ini ya, kita tuh memberikan fondasi ya. Fondasi untuk memberikan pemahaman tentang sains dan engineering. Jadi bagaimana kalau misalkan kita ada problem gitu ya di masyarakat gitu, saat kita ingin memberikan solusi, nah kita tuh harus lihat nih ilmu-ilmu apa yang available ya di science gitu. Jadi berbeda misalkan ya kalau kita berbicara dengan bidang yang lain itu akan menggunakan metode-metode yang sudah mature gitu ya, yang sudah developed, oke. Nah, di engineering physics kita lebih berinovasi untuk ngulik nih ya, mengulik apa yang ada di fisika, kimia, matematik begitu ya, biologi bahkan untuk diaplikasikan ke engineering. So engineering physics apply not only physics but all science to tackle 21st century engineering challenges. Okay. So now I have a question. So this is all the stuff we know in this century or in this millennia. So we know this one. So maybe okay. So Clara already joined us. So Clara, I guess, is from ITB. Students, right?
Yes, Papaki.
Okay. So Clara is my student. So it's okay. So Clara, do you prefer in English or in Bahasa?
It's all right.
Okay. Okay. So if you have any question, please raise hand or just open mic and then start asking a question. Okay. Okay, Dion and Clara. So this thing is the thermometer gun. Okay, so we know in this COVID era, we use this massively. Okay, in mall and then in the shopping center and then maybe some part of the area in schools. Maybe when you enter the class, you need to measure your temperature first. So this thing is quite simple in shape, in technology, but actually inside of this quite complex because we have to measure the temperatures from outside without contact. Okay, so that's the technology from sensor technology. So it detects temperature not on contact and then transfer the signal, okay, from lights, infrared to readings to numbers. Okay, and then the displays. So this kind of technology, we developed this in engineering physics, but the problem or the object, it's not human. Okay, it's not only human because we also measure things in industry. Okay, so in maybe a flood sensor or a congestion sensor for traffic control system. So we use this as methods to measure things, okay? And then we also can measure multi-scale physics phenomena. For example, this thing is the small animals, ants, but we can also measure things like electron or materials in nanoscale, okay? So we measure from macro scale to nanoscale. Okay, so this is what we focus on in measurement because this is the key, in the future. This is the key. The measurement is the key because we want all information around us. So for example, in our house, so if you want to get the temperatures of the room, we need to put like temperatures and then the maybe pressure, we need to put the sensor pressure. And then if you want to control everything, lights, you need to measure the lights. If you want to control the electricity, you need to measure the electricity. Okay, so the consumption, energy consumption, we need to also measure that. So if we want to connect with this with this system, okay, because in the future, all around us will be connected. Okay, the physical system will be connected. So this kind of technology is only the beginning. Okay, because in the future we will be connected with all of things around us. So and then that's the measurement system. Okay, and then we know these drones. Okay, and then this is the robot arm. Okay, so this is the autonomous system. The autonomous system, like this guy can fly around, and then you don't need to stabilize this thing, because when you turn it on and then fly it away, it will stabilize by itself. So we call this autonomous system because it's stabilized by itself. So this is also the future, because now we still control this thing. Okay, some part in the industry, in the manufacturers, none of us control this thing. Okay, because this guy already autonomous, but these drones, we still need to fly it. Okay, we still need to drive it, pilot it. Okay, so if we need this drone to fly to some point or trajectory, we need to control this. Okay, using remote control. But in the future, maybe we don't know. But sure, it will be happen when maybe some delivery service using drones to deliver stuff to your house. Okay, so this is the future, also the future. And then at the pictures below. Okay, so I will be asking. I will ask Dion. What is this, Dion? Hello, Dion. This is a solar panel. Okay. Solar panel ya. Ini jadi kita bisa ngambil sinar cahaya ya, pakai solar panel ini menjadi listrik. Oke. Dion pernah lihat nggak ini? Halo, Dion?
Ya. Ya.
Halo, kedengeran suara saya?
Ya, kedengeran.
Kedengeran ya. Dion pernah lihat ini nggak, Dion? Solar panel.
Oh, pernah.
Pernah ya. Nah, jadi di masa depan ya, kita itu kan sekarang masih tergantung sama energi minyak ya. Energi minyak yang banyak banget gitu di alam kita, yang kadang-kadang tiap tahun itu selalu ada masalah ya dengan si minyak ini, bilangnya kita kekurangan sumber minyak begitu ya. Tapi ada nggak sih alternatifnya? Nah, salah satu alternatifnya adalah solar panel ini. Jadi solar panel ini ya, setiap tahun ya dia itu bisa menambah terus ya efisiensinya. Jadi mungkin tahun depan akan ada solar panel baru yang efisiensinya lebih tinggi, sehingga kita bisa menangkap lebih banyak sinar matahari yang berubah menjadi listrik ya, dengan menggunakan teknologi yang terbaru. Nah, ini ya yang banyak menjadi permasalahan adalah bagaimana kita mengambil energinya, terus kita mencharging baterainya ya, itu menjadi permasalahan. Karena kalau kita punya solar panel yang banyak, berarti kita harus bisa ngecas baterai ya. Nah, dan juga ya di Indonesia kita sudah ingin membuat ya pabrik baterai di Indonesia ini. Ya, jadi teknologi baterainya ya harus disesuaikan juga dengan kemampuan pengambilan energi dari solar panel ini. Nah, di teknik fisika kita melakukan penelitian tentang ini ya sangat intensif ya. Dan juga mahasiswa kita juga diajari ya bagaimana caranya memanage energi dari energi terbarukan. Okay, so this will be the future ya. Ini akan jadi this will be the future of energy mining. I don't know energy how ya. Jadi dia akan ngambil semua energi dari sini. Oke. Okay? Nah, lalu kita juga punya ini ya, small technology. So this one is the noise cancelling headphones and then smartwatch ya. So in the smartwatch technology, we know that we put almost all sensors in this guy. So we have a gyroscope. Okay, so compass. We can use compass with this gyroscope sensor. And then we have accelerometers. And then we have blood sugar sensor. And then heartbeat sensor. Okay, so this thing is quite futuristic for now. But in the future, like imagine if we have clothes, okay, with sensor embedded inside it, yeah, with the same kind of readings, sensors, so that maybe will be happen in the future. So all of this stuff we know that already exists today. Okay, already exists today, but in the future, maybe we will advance into something new in a technology. So in engineering physics, we always innovate, to generate new solutions, okay, for future challenges. And then we commit to always put new science to engineering. Okay. So next, okay, so this is the top 10 job skills of tomorrow and how long it takes to learn them. Okay, so the first one is the analytical thinking and innovation. Okay, and then active learning and learning strategies, complex problem solving. So if we want to solve something complex, okay, we need to know all fields or almost all disciplines, the basics, the fundamentals. So we can compile all the sciences to solve a complex problem. Because if we only know one disciplines, we only can solve the problem in only one area. So if we want to solve a complex problem, we need to know almost every scientific area. Okay, and then that's the problem solving skills. And then we know the critical thinking also important, and then creativity, leadership, technology design. So in this technology use, monitoring and control, and then technology design and programming, we put emphasis on this for students to use modern technology, okay, progressive technology, like machine learning today. We push our students to use that technology to solve engineering problem. So top 10 skills in 2025, we push today in 2022. And then we started this from 2019, okay? Because based on the international accreditation, we need to push all of this to our students. So because we already accredited by international association since 2012, so we need to keep this in mind. Okay, so that is the top 10 skills, and we already pushed it since 2012, and then continue to the new curriculum in 2019. Okay, so that's what students will get in engineering physics. Okay, so if we sum up the top skills, the first one is the problem solving, okay, and then technology use, self-management, and then working with people. Because if we, put these skills, only problem solving skills, and then technology use, development, and self-management to students, so we create a students who cannot working with other people. So it makes arrogant students. So we make sure we push our students to work with each other, not only within the course, not only within the program, but also across program, or doing internship outside the ITB. So that's the objective for the students. Okay. So if we see what is engineering physics, so it's quite confusing, because some of the people say that engineering physics learn everything too broad and do not have a specific skill set. So some part of that is true, but we learn all of this, okay? Electrical engineering, aerospace engineering, mechanical, chemical, civil, or material engineering, because we want to put the fundamentals, the engineering fundamentals to our students. So in the future, because we know that in 4 years in undergraduate program, almost all programs, the students will only get the basics. Okay, so all students after graduate, okay, they still need to learn new skills, because today all engineering methods is developed so fast. Okay, it's developed so fast, and then we need to still to learn everything after we graduate. So in engineering physics, we put the fundamentals So after graduate, okay, you can sharpen your skill sets based on the needs of the society. Okay, for example, for today, if you work after the graduation in the aerospace industry, you need to learn about the aerospace deeply. Okay, more deep and then deeper. So you need to learn that. So in engineering physics, we already give you the basics, so you can learn by yourself. So the long life learning is one of the spirits of our students after graduation. So di sini ya, ilmu teknik fisika itu mempelajari semua ya. Nah, mempelajari semua yang berbasis natural science dan teknologi. Okay, so we learn about the basic of electrical, and then we learn about the aerospace and then the mechanics, okay, and the materials and everything in engineering. Okay, and then so there's also the questions: what is the difference between engineering physics, science, and the other one is the physical education, not physical education. Apa ya bahasa Inggrisnya? Pendidikan fisika lah ya, fisika untuk pendidikan. So the differences are this. Okay, so the first one is the education, yeah, physics for education. So in this program, the output of this program is to be a teacher for high school, middle school, okay, to teach students, okay, teenagers, physics. Okay, so that's the outcome of this program. And then the second one is the physics science. Okay, the physics science program. So the outcome of this program is scientists. So you need to, if you choose to be to enroll in the physics science program, the outcome is like you have, like you will learn about how to prove the physics law, okay, or physics phenomena through experiments and then theoretical approach. Okay, so the outcome is to be scientists. So in engineering physics, the outcome of this the students is not being a scientist or a teacher, but be an engineer. Okay, an engineer. So in engineer, like you need to apply, okay, physics, not invent or discover new physics law or new phenomena, but you apply it. You apply the physics science or chemistry or biology or almost all science to engineering. Okay, so that's the engineering physics. So in this case, okay, we are the bridge between the physics science and then engineer, because we need to explore a new the new physics law or maybe physics theory or anything new findings in physics. If we want to advance the technology, we need to apply it in engineering physics. Okay, so that's the position of engineering physics between engineers and science. So we are the bridge between them. Okay, so we can translate engineering problem, okay, what we need in the physics phenomena, what we need to discover. So we can tell the science guy, okay, so the problem in engineering, we still lack of something, okay, in maybe some areas. So we can talk to the science guy and then, hey, you need to discover more on this phenomena, okay? Or we can give, okay, the empirical results from engineering to science. So based on your findings, your findings can be implemented or not. So we can confirm that to the science guy. Or from the scientific era, new findings may be invented or discovered at that time, and then we want to apply it in engineering. It also can happen. Okay, so we can advance new solution in the engineering area. Okay, so that is engineering physics. Okay, so as engineering physics, we can talk with almost everyone. Okay, we can talk to a mechanical guy or electrical guy. We can be a programmer. Okay, we can be putting together, like electrical parts or moving parts like machines like this. So we can mingle around, okay, with people as long as it's related to engineering and natural science. Okay, so if you want to be a kind of guy who can talk, to other people, talking things with technology, engineering physics is your place. Okay. And then the next one. So what is engineering physics? Okay, so what you will study in the engineering physics? Okay, so we will see what is the inside of this engineering physics. So the first one, okay, the first one is it's all the same with the new year student, freshman year students. Okay, the first year, like you will learn about fundamental sciences, like Clara, yeah, like Clara. Now, because Clara is still in the first year, you will learn about the fundamental science. Okay, physics, math, chemistry, programming, basic design, and languages and sports. That's the interesting thing with the ITB, because not all university in Indonesia putting sports in the curriculum. Okay, so only us maybe, and maybe UPI, yeah. So we will learn this in the first year, and then in the second year, we will learn about the fundamental engineering sciences, where we will learn both in engineering methods and then science. Okay, in this, we will learn some part of the engineering methods, okay, like engineering math, and then science, like some of the, I don't remember the numerical methods, okay, in the second year, digital logics, and then physics, mathematics, and then yeah, like you can we will see after this slide. Okay, and then in this you will be exposed with the electrical and electronics related courses, mechanical, chemical, material, information sciences related courses. Okay, and then the third year, like you will be you will get the multi-physical approach in engineering methods. Okay, so in this, we will jump deeper into the engineering methods. Okay, for example, like we'll learn about thermal and thermal system, acoustic system, control system. Okay, in third year, and then also as international program, not international program. Apa ya Pak Naren bahasa Inggrisnya? Jalur internasional ya. So in this
international track, maybe.
International track. Okay, so in the third year, in international track, you will suggested, okay, or encouraged to do the summer school, international internship, and industrial internship to get the exposure of international track. Okay, so in the third year, like you will encouraged to do this. And then also there's also in the summer short semesters, okay, summer school and internship activities. With MBKM, Merdeka Belajar, it also opened a new opportunity for you to do internship in longer period. For example, for a semester, like you can use that credits to do a full-time internship in industry, okay, or maybe exchange with overseas student. And then in the fourth year, There's also the international academic exchange and then research exchange. So you have the network if you enroll in the international track. You can do exchange with overseas university, or you can do the final project or the research overseas. Okay, so in the next slide, a couple slides next, we will see our partners today. So in the future, we will expand more the network to another overseas university. So after this, after 4 years, you have also choices for your future. For examples, you can choose to graduate, or you can do the fast track or double degree. So if you do the fast track, you will advance to master's degree, okay? Or we can say it's a postgraduate, okay, postgraduate track. So it only requires 5 years maximum to get the master degree if you're continuing from the 4th year to take courses from postgrad, okay? And then, or you can do double degree, okay? For examples, you can do this double degree from at the overseas university. So you will get ITB certificates and then overseas certificates, okay? So this is the structures of the curriculum. It's not the curriculum, it's the skills of what we will get in engineering physics. Okay, so for examples, this is the first year, you will learn the physics, okay? And then you will jump into engineering physics. So what is the uniqueness of the engineering physics? For examples, engineering physics is the only engineering program that learn about the quantum mechanics. So in ITB, or maybe in Indonesia, like only us, engineering courses, engineering program, who learn about the quantum mechanics, okay? And thermodynamics is quite engineering, because in physics, they are not learning about this, okay? Thermodynamics, because it's too engineering to be a science, okay? So we learn about this quantum mechanics. Why we learn about quantum mechanics? Because in the future, you know, like today we move from micro scale to nano scale, and then you know, our processor now using the nanoscale technology, nanometers, okay, to create the transistor inside the processor. And in the future, maybe if we can push this to solid state technology into nanoscale, we require quantum mechanics, okay, to understand the phenomena in the semiconductor. So this is quite interesting, because we learn about this, and then today we already apply this into some technology, okay? So that is the structures of engineering physics. So if you want to be a quantum scientist, but you don't want to be a scientist, okay? If you want to apply this quantum mechanics into engineering physics is your place, okay? And then the next one is we utilize this broad principle of physics for examples, okay, to various engineering problems. So our students, okay, will understand the fundamental physics, okay, with several select engineering core courses, because we are not teaching all engineering core. For example, so we do not teach the oil phenomena, for example, but we teach the fluid phenomena, okay, and thermal phenomena. And then we expect our students, okay, our alumni is versatile enough and quick with adaptability to learn new skills or contribute in solving various problems and challenges, okay, based on the field of engineering depending on his or her further interests. So for example, if in the future you really want to be programmers or software engineers, like you can use this, okay, mathematics for science and engineering and numerical methods to be a programmer in the future, okay. And it's not only restricted to the programming. Maybe in the future, if you stumble upon the quantum computers, you already know about the quantum mechanics, okay. So that's a big win for engineering physicists, okay. And then in the next step, so this is the skill set, okay, the skill set of engineering physicists. For example, in the first one, we can be electrical and electronic engineers because we learn about this: control theory, analytical dynamics, signal processing, digital logic system, and then electronic circuits. And then we can also be mechanical engineering because we learn about thermodynamics, okay, because thermodynamics is the basics in machine, okay, in the automobile or automotive. And then analytical dynamics, it's also used in that area. And then mechanics of materials, if you want to be in the aerospace, how to build an airplane, because you need to know about the mechanics of materials. And then also fluid mechanics, okay, and then heat and thermal transport. And then if you want to be a chemical engineers, you also already know about this, and then you learn about the thermo and kinetics of materials. So that's quite strong fundamentals if you want to be chemical engineers from engineering physics. Then also this, the material science and engineering, because we learn about quantum mechanics, electromagnetics, and then we learn about the physics of materials, material characterization, and then processing materials. We can be a material scientist, okay? And the fact that engineering physics is the strongest materials engineers, and then research, okay, material related area, the research is the strongest in ITB, okay? And then the next one, so this is the maybe the most wanted area today, the information science and engineering. So in other courses, in informatics or computer science, the outcome is to be engineers who can build a system, okay, who can build a system or put a solution to solve problem in the information system and then the computation. But as engineering physicists, because we learn about physics phenomena or phenomenon, we need to put the physics first, okay? So in this area, we can be Internet of Things engineers or industrial Internet of Things, how to send the measurement from one place to another place. For example, if I want to get the weather, okay, from Sydney or from London, in Sydney or in London from Indonesia, I can do that, yeah. So that's the maybe snippets of the Internet of Things. So imagine if you want to measure things in our house from our office, so we can do that with Internet of Things. So in engineering physics, we learn about this, okay? And then also data science and engineering, we claim this because we know the phenomena in the nature. So we already know everything with the measurement. So what we can do is how to put all this data to be more meaningful for society. So that's the data science and engineering, okay? And then also we learn about the advanced engineering and then computation. So all of this, you can be whatever what you want, okay, in the future. if you learn in or enroll in engineering physics. Okay, so that's quite broad in the skill, but in the future you can sharpen based on your interests. Okay, so this is the curriculum. So as I mentioned before, in the first two semesters, you will learn about the fundamentals, science, physics, and chemistry. And then in the second year, third semester, and then fourth semester, you will learn about the engineering science. Okay, engineering science, for example, you will learn about this electromagnetics, okay, and then electrical, probabilistic, okay, and then computation, and then etc. And then move to the third year and fourth year, you will learn more about the engineering approach. Okay, so you will spend 3 stages. The first one is the basics, and then the engineering science, and then full engineering courses, okay, in the last 2 years. Okay, so that's the what is engineering physics. So I will give you opportunity to ask questions. So maybe this is the time. So for Dion or Clara, kalau ada pertanyaan, boleh disampaikan, boleh bahasa Inggris atau bahasa Indonesia, senyamannya aja. Silahkan. Silahkan Dion.
Yeah. So, can you hear my voice clearly?
Yes, I can hear you clearly.
Wait. So my question is, sorry if you have to explain once more, but what is exactly the purpose of learning all methods of engineering if in the end we have to learn more about the specific engineering?
Okay, thank you. That's the good question. Okay, so we will go back to these slides. Okay, so in engineering physics, we learn about all of this. Okay, and then in the future, maybe if you get a job specifically for the electrical and electronics engineering, for example, if you maybe work in our government, okay, maybe in the PLN, okay, so you will only use this, maybe, okay, but in the future, okay, if the technology in electricity advance into the maybe more smart electricity, for example, if we use the smart transport for electrical, for examples, yeah, so you will need skill set from information science. Okay, so as electrical engineering, if you graduated from electrical school, okay, the problem is you don't have enough information or skills in this area. Okay, so you will need to learn from zero. But as engineering physicists, you already know about this, so you can just remember again what you have learned in the university and then apply it into this area. Okay, and then also this will beneficial if when you maybe get promotion. Okay, so maybe you work with Pertamina, for example. Maybe you in this skill set, you will only use the chemical engineering skills. Okay, when you got promotion, because you know about the information science, electrical, mechanical, and material science, you can lead. Okay, you can lead various type of engineers, and then you know what they talk about, and you understand what they maybe the suggestion from your colleagues. Okay, so that's the benefits of learning all of this thing. And then when new technology in the future maybe emerge from one of this, you can easily grasp what is the idea because you already know the basics. So that's the spirit, Dion. And then this also give you a basis, okay, to think as a system. Because when you are mechanical engineers, you only think as a mechanical engineers. When you are a chemical engineers, you only think as chemical engineers. But if you an engineering physicist, you will think in the different scope, okay, different hat. Like you will think as electrical engineers. If you want to use the approach as information science, for example, if you want to put like probabilistic computation into the solution, you can do that. So that's the why engineering physics give more, but give a broad courses or materials or skills to our students. So that's the answer, Dion. Atau bahasa Indonesianya ya. Kalau bahasa Indonesianya gini. Kalau bahasa Indonesianya, kita tuh belajar banyak ini ya supaya nanti ke depannya kalau misalkan kita ketemu dengan permasalahan, misalkan kerja di PLN gitu ya, ternyata ada masalah mesin begitu. Nah, kita misalkan banyaknya kan elektro ya. Nah, pas ada permasalahan mesin, oh kita bisa jadi ngurusin itu juga ya, karena kita sudah tahu tentang mesin gitu ya. Nah, misalkan lagi kamu promosi nih, jadi high level ya, yang mengatasi, menjadi atasan gitu ya, di mana di bawahnya kamu tuh ada yang electrical, mechanical, chemical, material ya, terus mungkin ada anak informatika gitu. Nah, kamu bisa melead mereka semua gitu. Ya, bahkan kita tuh beberapa juga banyak yang jadi CEO ya, yang bikin perusahaan yang meng-hire jurusan-jurusan ini begitu. Ya, itu adalah engineering physics. So it's quite challenging. So I cannot say engineering physics is easy. It's hard ya. Karena kita harus belajar banyak gitu. Tapi ke depannya ini jadi versatile. So if silakan Pak Naren.
Okay. Just want to explain a little bit more about the flexibilities, not flexibilities, but versatilities of engineering physics program. So in terms of the technological development right now, as you may also understand that during the last 10 years or 5 years, the technologies change quite rapidly, right? So every year, the technologies is going faster, smaller. So from the point of view of this broad understanding in engineering physics, so as the engineering physics lecturers and then as a communities, we want to prepare our students to be ready whatever it is the challenge will come in 10 or 5 years. Because for example, when Fakih and I graduated like around maybe 10 years ago, and then everybody's want to go to the oil and gas company. But now, as I understand and I'm aware that almost all of the students want to go to the online based companies. So in 10 years, the shifting of the job field is very dramatic. And then for you as the high school students, maybe what you are facing in the next 5 years, we never know. So maybe online merchant and also the industries is nowadays very, very high demand, but we don't know. In 5 years, maybe it will change again to telecommunication or the manufacturing or something like that. And then as we are also aware that Industry 5.0 will come back with the human factors. So now it's all of the technologies want to be automatic, like the AI, and if you maybe know nowadays a very, very automatic flavor in our technologies. But what I read from the paper, Industry 5.0 will come back with the human factors. So that means the human understanding about the physics, the human understanding about the natural phenomena is important, not only about the automatic issues or machine learning, something like that. So the point is we want to prepare our students to be ready for facing whatever it is in the futures you are, will facing in the future. So maybe that's my point.
Yeah. So from our TRESA studies, our alumni, so it's quite funny because before us as graduates of engineering physics, almost all the alumni is working in the manufacturing industries. Okay, for example, Nestle or some part of the PLN, and then also not Pelindo, the one who built the submarines. Okay, so it's quite mechanical. All the problems is quite mechanical, and then also in the buildings, okay, as AC engineers, and then after a couple of years, it shifted into oil and gas company in our era, and everyone want to get a job in the oil and gas company. And then what happened with engineering physics? We have almost half of our friends, okay, working in the oil and gas company. So as the era move on, engineering physics still relevant. Even today, in our students doing internship, okay, in a digital startup company, for example, in Gojek and Bukalapak, Tokopedia, and then also we have adik kelas. I don't know how to call it in English. Also work in the Gojek company, startup company, even building or found their own company in a digital startup. Okay, so we don't know what will happen, as Panaren mentioned before, in the future, but we make sure our students get all the basis, the fundamentals. Because, for example, if I predict in the future, like we will put human into the 4.0, where the human will have to know, okay, people have to know what is the mechanics behind the automation, because we don't need any operators anymore who operate the machine. We only need people who develop the machine. So maybe that's the future, when like we want to put this into our student. And then as in the future, we will also revise our curriculum based on what is the future. We always think about that. That is why in the 2019 we put data engineering and then Internet of Things into our curriculum. Okay, so that's in 2019, before the pandemics. And then now in the pandemics, it's accelerated like crazy, right? All the startup company, online company, and then Internet of Things, accelerated quickly. And then what we did, in 2019 to change our curriculum and then put this thing forward. So it's beneficial for the students actually today. Okay. So another questions, maybe if Dion still have any questions, or Clara. No? Okay. So we will see the facility and then the labs, okay, in our program. So it will be the same with the regular program. Actually, in the international track, so you will get same with the regular class, you will taste also the same laboratory. So not that there's no differences between the international and the regular class. The differences is you have the opportunity to do international internship and then exchange. Okay. So the first one is we have the building physics research group, where we will learn about the thermal, okay, and then the built environment, okay, and then the acoustic, and then lightings. And then we learn also about the automation in instrumentation and control and measurement. So we have the industry instrumentation, and then control and decision system, intelligent system, artificial intelligence, optics, and then imagery, and then a laser, okay, laser, and then also ultrasonic, sonics, and then medics. And also we learn about the engineering management, okay, and then the new renewable energy. We also learn about this, and then the material science, advanced, and then computational material. So this is the acoustic lab. So we have quite big facility with the acoustics. So we have, this is the full anechoic acoustics, where your voice is fully damped in this room. And we have also the echo chamber, where your voice will be live in this room for about 10 seconds. Okay. And then we also have the soundscape. You know, when you are in the movies, okay, like you will movie theater, like you will hear, you know, the sound system is maybe Dolby Atmos or something like that. So we create this as a 360 soundscape, okay. And then also we will learn skills with the electrical and then digital logics and then measurement in our instructional laboratory. So this is the common labs. So you will get the experience about this labs, okay. And then we also have this is the environment, the built environment. So we, in this case, is the thermal environment. Like you will learn how to control the thermal properties of the room, or maybe, you know, chiller and something like that. And then you will get the taste of energy management, how to change between renewable energy and then grid, for example, from PLN. So how to switch between maybe, you know, solar panels and then grids from PLN. So in this lab also already have clients, for example, hotels, and then government building. And then also we also develop our technology in our own building in LabTech 6, okay? So this is the management energy. And then we also create, okay, materials for sensor or advanced material with the advanced properties, where these materials may be not available in nature. So we create artificial materials with the specific characteristics. Okay, so we use this computational to simulate the materials, and then we can develop it using these tools. Okay, and then also we have this control decision instrumentation for industry. So we have a lot of facilities to learn about what happened in the manufacturers and then industry and then process industry process plant. Okay, so we have this. And then if you are interested in medical sciences, okay, if you really want to be a doctor but you cannot, okay, and you are not interested in, so you don't interest in any biological materials, you can learn about this from engineering perspective. For example, so you can learn about the signals from brain, Okay, so or you can learn about how to do simulation with our bodies or anything with the organic creatures. Okay, and then also we have this optic measurement. So this is quite beneficial for example, cosmetic industries, or you need to measure things without destruction or non-contact measurement. You can use optical approach. Okay. And then also we learn about intelligent control. One of them is using drones, automatic cars, and then electrical motors. And then we also create nanorobots, like small robots to do inspection. Yeah, and then we learn also about ultrasonics, like you will get access to this ultrasonic hardware. And then we also have innovative technology. For example, this is the batik photonic. Batik photonic is now it's in Batik Komar, in Bandung. So they use the light rays from our actuators here to put the batik to dry without sunlight. Okay. And then we have also Klungbot or Angklung Robot. Okay, so we created this so the musician or the one who compose musics for Angklung, they don't have to put the people all together just to test their composition. So they can use the Klungbot to test their composition. So it's efficient in time because you don't have to put the team together to only check your composition. Okay, so they use it. Okay, so it's the doctoral research of our one of our lectures. Okay, and then this is the robotic arms. So this is one of the project for students. So they develop the robotic arms to simulate in manufacturing, the robotic arms. And then we also have this industrial instrumentation where the students is required to put together all this instrumentation, industrial instrumentation, to create one system of automation or measurement. Okay, so that's the facility. So if we talk about engineering physics, where engineering physics in Indonesia? So it's quite few. Okay, because it requires the lecturers, to be able to teach almost all of the area, the disciplines into the students. So not all universities have the the team or the resources to open the engineering physics program. So it's only quite a few. For example, us, ITB, as the oldest engineering physics in Indonesia, and then ITERA, Surya University. So this is the STTMM, Muhammadiyah, Telkom University, Gajah Mada University, and then ITS, National University, and then Multimedia Nusantara University. Okay, so if you enroll as engineering physics students, you will be like quite a few guy in Indonesia, because it makes us special. Okay, it makes us special because if they really want to get instrumentation engineers, so we have the opportunity to be the one. Okay, in Indonesia. Okay, so our partners. So this is the partners for international program. The first one is this is the already confirmed partners. The first one is the Hong Kong Polytechnic University. Okay, and then UTP, University of Technology Petronas in Malaysia, and then Osaka University in Japan, Tsukuba University in Japan, and then Queensland in Australia, and then Gannon University in USA. So this more to come. Okay, because we still contacting our prospective partners in the future, because we also have alumni in several universities overseas. Okay, Okay, so we will see the prospect of engineering physicists graduates. Okay, so the first one is the software engineer, process engineer, mechanical, acoustics, electrical. This is the built environment, heavy AC, and then material engineers. Okay, so first one, you can be a engineering consultant. Okay, with this skill set. Okay, or you can be a researcher. If you want to continue your study, you can be a researcher or be a lecturer like us, like me, and then Panaren, or be an entrepreneur because you know all these things, and then you can create your own company, build a new technology, for examples, or build a new consulting or contractors. You can do that if you want to be an entrepreneur. Okay, so we will see the examples of this thing. Okay, this prospects of engineering physics with our alumni. So the first one is Saikunas El Mutakin. So he was graduated in 2019. Okay, so now he works in land industry in Bandung, and then he moved within the land to the railway system and train control managers. Okay, so this is very interesting because the railway system in engineering, maybe it has to be related to electrical engineering or civil engineering, because civil engineers, they learn about transportation. Yeah, but in this case, engineering physicists take this job. And then in 2020, last year, he was appointed as engineering executive vice president, okay, for engineering in land railway systems. So this is what I was mentioned before, Dion, why you need to learn broad disciplines, because maybe when you get promotion, you need to know about all that stuff, because you have to direct maybe your colleagues from mechanical, or leads your colleagues from material science or electrical science or electrical engineering, something like that. Okay, and this is what we can achieve as engineering physicists, even it's not directly related into engineering physics. So this is the industry from electrical. Okay, so and then the second one is Widodo Dwi Putro. Okay, he was graduated in 2010. Okay, and then this is quite interesting. He had worked in the business process analyst for balanced scorecard system at PT Kompas Gramedia. It's also not related whatsoever to engineering and science, but it's quite tied with the business and management, right? So our graduates, our alumni can work in this area, okay? And then after that, okay, Widodo founded a company called Prakerta Indonesia, okay? And then in 2015, he decided to continuing his study in laser and optic engineering. So he decided to move back to his track as a physicist. And then after that, in 2018, he worked until now in Germany in the Forjet Group Alsdorf as laser and optical engineers. Okay, so it's quite interesting. Yeah. So the next one is consultants who work in consultants. Okay, so they continue learning, okay, about this. So the first one is Nogista and then Feby. So they are husband and wife. Okay, so Nogista learn and then continue his study in energy system. Okay, but Feby continued her study in audio acoustics in Salford, UK, and then they work in the same company. Okay, and then Nogista, because he worked not in the energy system but in acoustic and vibration, he continue his study again in sound and vibration. So that's no, it's a work. Yeah, that's true. Okay, so they continue to study their study. Okay, even with different area disciplines. So for example, Widodo continue in laser and optics engineering, and then Gista and then Feby continue in acoustic vibration engineers or science. Okay, and then the next one is Bowo. Bowo graduated in 2015 and then built his own company as PT Biops Agrotechno in smart farming. Okay, and then continue his study in instrumentation and control in ITB. Okay, so he's one of our best student because he led robotic team in engineering physics, and then decided not to work with companies but make his own company, PT Biops. And then we also have notable alumni. So we have Bapak Kusmayanto Kadiman, who was the Ministry of Research and Technology. And then now we have Prof. Fadel Muhammad, who is now is the vice of the MPR RI, and then was the Ministry of Fishery and Seas. Okay, and then Ibu Karen as CEO of Pertamina, and then Bapak Yuda Setio as CEO of PT Icon. Okay, and then also the Senior Executive Vice President of PT PLN from 2019 to 2020. And then we also have CEO and top level management. The first one is Arya Hidayat. He is one of the what you call it? One of the famous developers in Silicon Valley. Okay, he invented a library JavaScript called Arrow, and then now he is the co-founder of Hyperjump, VP of Engineering Shape Security. Okay, and then the second one is Rivi Rayuwana, with the CEO of PT Reka Cipta Teknologi, and then also Rashid Ridho in Smart Eco Indonesia, CEO and founder, and then Ariandi, my friend, co-founder and head of software development and AI Selumation in Germany. Okay, and then we also have alumni who works as an engineer and then consultant. One is Sandy in Saipem, and then Adewinata, Unilever Australia, and then Benny Kusumatmaja in OTC Wireline Field Engineering in Turkey, the one who discovered new well, okay, for OTC, and then Hanifan, who work with the GE Healthcare. Okay, and we also Riandi in Chevron, oil and gas company, Sigit Aditya in Nutrifood, food and beverage company, Francisca Vivianti in Islam Bersih in the consulting and contractors, and then Amanda in Orga BV in Netherlands. Okay, and also we have with the professionals. So previously we talked about professionals, and then the next one is researchers and academia who work with the overseas university or overseas research institution. So the first one is Satria Wicaksono in Singapore in Nanyang Technology as a senior research fellow, or we call this as a postdoc. And then Hari Septanto in Lapan, Indonesia, Abdillah Digdaya, Caltech, California Technology in USA, and then Thomas Budiarto in Process Dynamics and Operation Group, TU Berlin, Ken Sandy Pang in Nottingham University in UK as assistant professors. Okay, so maybe now he will be advanced into professors maybe in a couple of years. And then Rian Budiman in Japan as advanced industrial science and technology. And then Cica Gustiani, postdoc researchers in Oxford with topics quantum computation. Okay, and then Edo Raihan, researchers at PT Pertamina, power and storage system. And then Ananta, postdoc in Hiroshima University, Japan. Okay, so if you see yourself as a engineering physicist, join us. If you want to get, if you really want to get broad disciplines around engineering and science, engineering physics is for you. So maybe that's my presentation. So this is our last slide. So if you have any question, please don't hesitate to ask us. Thank you. Silahkan kepada Dion atau Clara jika ada pertanyaan. Oke. Kalau gitu saya mau nanya, Clara, silakan Clara.
Oke, saya izin pakai bahasa Indonesia ya Pak.
Nggak apa-apa, silakan.
Untuk saya ingin bertanya mengenai program kerjasama yang seperti riset internasional dan mungkin student exchange itu ya. Kan saya sebagai mahasiswa yang sudah diterima dan sudah peminatan di teknik fisika, apakah ada kesempatan juga untuk mahasiswa reguler untuk bisa mendapatkan program untuk international track itu? Ataukah memang hanya dikhususkan untuk yang mengambil program internasional?
Oke, ini saya jawab dulu sebagai reguler ya. Nah, kalau di reguler, kita itu ada kesempatan untuk melakukan pertama magang ya di luar negeri. Tapi nanti SKS-nya kamu harus ngambil cuti. Gitu Clara, bedanya. Misal nih, kamu dapat kesempatan magang di Jepang misalkan ya, 1 semester nih. Nah, 1 semester itu kamu harus nggak ngambil SKS di ITB gitu. Jadi 1 semester itu kamu kosong, 0 SKS untuk ngambil magang di luar. Gitu, karena kalau misalkan yang reguler itu yang setahu saya ya, itu tidak bisa diakui sebagai SKS. Kecuali kamu ngambilnya universitas yang udah ada kerjasama sama ITB di double degree tadi. Gitu, Clara. Jadi misalkan kamu kuliah di sini gitu ya, terus tugas akhirnya di sana misalkan, bisa di luar negeri, tapi dengan universitas yang udah ada udah ada MOU-nya kerjasama gitu. Gitu, mungkin ada tambahan dari Pak Naren, silakan Pak.
Iya, jadi Mbak Clara udah masuk ke peminatan TF ya. Nah jadi gini, kalau untuk yang reguler sebenarnya kesempatan internasional itu terbuka juga. Namun bedanya dengan kelas internasional adalah kalau yang track internasional itu dari awal kita sudah plotting. Jadi dari tahun pertama kita sudah bisa menawarkan option bahwa kalau Anda mau masuk atau karena mereka wajib ya minimal 1 semester di luar negeri, maka kita sudah menyediakan kanal-kanalnya untuk ke luar negeri, universitas apa saja, dan biayanya berapa, dan kuliah apa yang bisa diambil. Dalam artian di sini kredit earning, karena kita harus transfer kredit kan dari luar negeri untuk diakui sebagai kuliah di TF. Gitu. Karena kan kalau Anda nanti lulus sebagai lulusan TF 144 SKS itu banyak kuliah kan. Nah kuliah ini bisa saja diambil di luar negeri. Nah itu ada proses kredit transfer namanya. Ketika diambil di luar negeri harus ada proses yang menyatakan bahwa kuliah ini tuh equal dengan kuliah yang harusnya diambil di TF. Jadi nggak harus ambil 2 kali. Nah tapi kalau internasional itu sudah diplot semuanya, sudah dikonfirm karena mereka harus pergi ke sana ya. Jadi dari awal sudah kami kerjakan itu, sudah kami fasilitasi. Nah, tapi kalau untuk yang reguler, karena Mbak Clara udah masuk, bisa saja sebenarnya ngambil kuliah di luar pun, kayak sekarang kan ada program ISMA, ada juga student exchange yang sifatnya kompetitif ya, biasanya ada seleksi dan lain sebagainya. Dan kredit transfernya betul yang kata Pak Fatih bilang tadi, kalau ada MOU itu bisa lebih mudah, tapi kalaupun belum, sebenarnya bisa saja. Tapi proses ekivalensinya itu nanti di belakang, dan itu kadang tidak menjamin bisa diklaim sebagai SKS yang ada di TF, bergantung dengan asesmen nanti ketika harus ada prosesnya ya, dilihat jadi silabusnya seperti apa, bahannya apa, asesmennya seperti apa, apakah nilai A di sana bisa sama dengan di sini. Nah, ada proses seperti itu. Nah, jadi kalau singkatnya sih bisa, cuman prosedur itunya tidak dipersiapkan dari awal. Gitu. Bedanya dengan internasional program itu di situ. Gitu. Tapi kalau bisa sih bisa, apalagi kalau research exchange.
Paling gampang ya, research exchange paling gampang sebenarnya. Ngerjain TA di luar gitu.
Kita lakukan, ya betul.
Sering
Dan
banget itu.
Kalau mau applied sendiri, kayak misalnya intern di luar, itu banyak ya, dengan MBKM juga sekarang, ya termasuk ISMA itu, kan MBKM ya, program MBKM yang dia bisa ngambil exchange 1 semester atau beberapa bulan di luar negeri. Itu boleh, tapi sifatnya inisiatif dari mahasiswa. Jadi tidak kami arahkan 100%. Kalau yang internasional kami memang sudah beri kanalnya kemana saja, begitu kami carikan jalannya. Tapi kalau yang reguler tetap kami dukung, kami support, tapi inisiatif dari mahasiswa karena tidak kami wajibkan. Gitu sih bedanya.
Begitu, Clara.
Ya, baik, terima kasih Pak Fakih dan Pak Nadim.
Ya, sama-sama.
Oh, berarti Clara udah di peminatan TF ya. Walinya siapa? Bukan walinya, bukan saya.
Pak Justin, Pak.
Pak Justin ya.
Waduh, Bapak ganteng nih.
Kita juga ganteng lah.
Ganteng kali. Oke. Ada pertanyaan lagi? Karena kita udah jam 5 nih. Nanti rencananya kita akan ada juga open house ya. Kita akan ada rencana open house untuk teknik fisika, di mana nanti materinya akan lebih seru ya, di mana nanti akan ada penjelasan-penjelasan dari laboratorium-laboratorium ya, bahkan dari kegiatan-kegiatan mahasiswa begitu. Nanti ada serangkaian program. Nanti bisa diikuti juga nih, mungkin yang buat peminatan ya, juga yang udah masuk ITB gitu, pengen ngelihat ada apa aja sih di teknik fisika, nanti kita coba akan bikin open house ya untuk teknik fisika. Nah, dan untuk Dion, so kalau misalkan ada teman-teman lain yang punya pertanyaan ya tentang internasional atau mungkin mau sharing juga, video ini sudah ada di YouTube ya, YouTube-nya teknik fisika. Kalau mau di-share ke teman-temannya supaya misalkan teman-temannya ada minat yang sama, silahkan. Nah, sebelum ditutup ya, saya ingin sharing dulu tentang ini, timeline untuk yang program internasional ya. Jadi sebenarnya program internasional ini gelombang pertama itu sudah akan ditutup di tanggal 30 ya. Nah, ini coba saya share screen dulu. Oke, share screen saya sudah terlihat. Ya, ini adalah kanalnya admission ITB. Jadi untuk melihat bagaimana cara daftar ke ITB ada di sini semua. Nah, nanti mungkin teman-temannya Dion ingin lihat, di sini ada info pendaftaran ya. Nah, info pendaftaran itu di sini ada banyak nih, ada program sarjana, pasca sarjana, ya, undergraduate sama graduate program. Nah, yang contohnya yang SNMPTN ya. SNMPTN itu kan akan berakhir di tanggal 29 ya. Itu hari Selasa besok. Itu kan ada pengumumannya. Nah, untuk international undergraduate program itu ada di sini ya. Jadi kalau berminat nih ya untuk masuk ke internasional, di sini ada syarat-syaratnya ya. Nah, untuk schedule-nya itu ada di sini ya. Nah, schedule-nya untuk periode 1 ya. Jadi sekarang adalah masuk di periode 1 sampai tanggal 30 Maret. Itu pertama untuk WNA ya, misalkan orang luar negeri. Ya, lalu ada WNI yang bekerja yang sekolah di luar ya, misalnya ada sekolah di Jepang atau di Australia atau di Amerika gitu ya, tapi dia WNI. Nah, ini bisa daftar ya di periode 1. Dan juga WNI di Indonesia mungkin yang tidak menggunakan non-national curriculum ya, misalkan gitu ya. Itu bisa mendaftar di periode 1. Oke, diprioritaskan. Nah, selanjutnya itu adalah di sini ya. Kita juga membuka untuk WNI dengan national curriculum. Misalkan Dion ya, Dion kan di BPK Penabur ya Dion ya. Nah, mungkin pakai national curriculum gitu ya. Nah, di sini Dion bisa daftar di periode kedua. Ya, jadi jalurnya ini adalah jalur khusus ya. Jadi nanti langsung masuk ke teknik fisikanya. Jadi nanti nggak usah lagi SBMPTN ya, masuknya di jalur internasional gitu ya. Nah, di sini student registration-nya adalah di tanggal 6 sampai 25 Mei ya. Tapi di sini kita ada tes dan registrasi, nanti ada pengumuman-pengumuman ya, drawing test dan sebagainya. Oke. Nah, lalu ada lagi yang periode ketiga. Ini gelombang yang ketiga, itu juga untuk yang ditambahkan dengan yang WNI dari sekolah dengan kurikulum nasional. Begitu ya, sampai tanggal 13 Juli. Karena kita kuliahnya di bulan Agustus mulainya. Biasanya kita sidang terbuka di 17 Agustus ya, sambil upacara gitu. Oke, jadi itu adalah informasinya ya. Jadi nanti kalau misalkan ada lagi untuk yang lain ya, di sini juga ada sebenarnya listnya ya. List yang international program itu, nah ini contohnya ya, di sini ada international class. Ya, ini full international, terus ada international track. Nah, engineering physics itu international track ya. Jadi kuliahnya bisa pakai bahasa Indonesia atau bahasa Inggris ya, karena masih track internasional. Kalau yang international class itu harus pakai bahasa Inggris harusnya ya. Kayak gitu. Oke, jadi itu adalah informasinya. Jadi kalau ada informasi yang ingin ditanyakan tentang pendaftaran, silakan masuk ke ini ya, Admission Institut Teknologi Bandung. Oke, jadi mungkin dari saya cukup sekian. Mungkin ada tambahan dari Pak Naren.
Mungkin tambahan sedikit sih. Jadi yang tadi udah dipaparkan tentang internasional track, itu nanti partnersnya dari beberapa universitas ya, Hong Kong Politeknik, lalu ITB, lalu ada Tsukuba, Osaka, Queensland, dan juga Ganon, dan beberapa diantaranya memang masih dalam proses penjajakan, namun sudah insya Allah positif begitu ya, dalam waktu 2 tahun ke depan kita akan berpartners dengan pihak-pihak di sana, tetapi juga kami juga akan menginisiasi dalam waktu dekat ke beberapa universitas lainnya seperti Tohoku dan juga University of Groningen di Belanda. Mungkin juga nanti dari kampusnya Pak Fakih juga bisa kita coba ya di Australia begitu. Jadi itu sih yang mungkin perlu diinformasikan saja. Nuhun.
Oke. Thank you. Ya, terima kasih. So that marks our time to finish our session today. So thank you everyone for attending this session. So for further information, you can follow us in Instagram, you can follow us in Twitters, and then you can rewatch this video or these meetings in our channel, in YouTube channel, Teknik Fisika ITB 133 or 133. So that's our student number. So thank you for joining us. So have a good day, good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you.
Thank you everyone.
Apa?
Thank you everyone, nganduaan guys. Di ini
Masih
dong, di
live,
stop
Pak.
dulu
Masih live,
dong.
Pak.
Masih
Gimana sih?
live.
Lagi deh.
Di-cut aja. Live-nya dimatiin.
Bisa gitu
bro.
live-nya di-cut.
Bisa. Diedit nanti.
Kumaha Pak, punten tadi telat.
Mana ini live-nya kok masih running?
Kok masih sih Rani, gimana mati ini harus dari Pak Fakih, ini mah bukan, enggak dari TF kali enggak?
Dari TF.
Siapa yang jaga di TF? Itu Om Ferdi.
Buka tuh. Yaudah saya masuk dulu lah ke YouTube-nya TF. Bentar ya. Bentar ya.
Sabotase aja, Pak.
Apa? Di mana ya? Nggak ada.
Passwordnya diganti yuk, TF kayaknya.
Oh gitu.
Sebentar ya, aku cek dulu, aku kasih ke Kang Opis. Kemarin soalnya ada yang pinjem mahasiswa.
Oh gitu. Oh iya, udah sign out saya. Ini
Mahasiswa
masih live loh.
Oh iya. Aku kirim ke Kang Opis ya. Eta nu jaga saat eta. Jadi
Rana.
Itu udah tuh passwordnya, aku kirim.
Iya.
Suka dipinjam buat live streaming juga sama anak S2.
Bentar. Kalem. Ini harus ngasih ini dong. Konfirmasi.
Ke emailku kan biasanya.
Masa sih?
Iya.
Nanti malam teh mau podcast jadi enggak?
Emang nanti malam jadwalnya?
Sama ini, sama TF, sama kelas terbuka.
Oh, ayo. Nggak tahu kapan, bahasannya apa.
Bahasannya tentang teknik fisika.
Lah bukannya Kamis ya kelas terbuka?
Enggak, besok ada. Nanti ada.
Mantap, ini meraup rupiah.